one about how it's been till now. Okay, audio is loud and clear. Thank you so much for your review. Thank you. Did we have any? Thanks for confirming. Did we have any, questions from the last class, like the last session we had? Be it maybe something interesting you found out when you did some of your practicals, some of the more technical things. Did you have like any questions, any observations, anything that surprised you? Maybe surprisingly harder than you thought, surprisingly easier than you thought. Just want to know how it's going for us. We'd love to just get some feedback. I know last week we finished up the AWS Solutions Architects part of the course. Okay, I see the account is typing. Just give him a second. You can also speak. Shell scripting is your major challenge. Well, you're in the right place. You're in the right place because that's what we'll be talking about today, right? If you want to speak, that's also fine. Just want to get some feedback. How's it going? What has been your major blocker? What has been your major achievement? So if you could share your major achievement, that would be nice. Maybe something that you didn't think you'd have been able to achieve, or something that from day one looked extremely difficult, but you got through it. I would like to get that feedback just to know what barriers have been broken, what sort of progress we have. Maybe I'll just take for one or two more people. You can put it in the chat before we kick off. Or you can use the raise hand feature also, and I'll just give you the ability to unmute your mic and speak. Do we have anyone? Or is everybody perfectly good? I mean, even if you're perfectly good, I'm sure you've had some major achievements, something you've done and you're proud of so far. Okay, let's have the please go on, Nico.
Hello, good evening.
Good
Yes,
evening.
one of my achievements is I was able to push my I like from when we started the GT bash, it was like wow, will I be able to even work on this environment, especially the CLI, and the fact that that thing can throw error at you every little instances. So I don't know how to use Git bash and also GitHub. So during the course, I was able to use the Git bash, then the GitHub, then I was able to push my website on the Amazon EC2. I mean, that's a
Oh wow.
major breakthrough for me. It was very big for me that day. I was just shouting up and down like, wow, I know I can do this. Yeah,
That's great. That's great.
yeah.
I
Thank
mean,
you.
that's awesome to hear. Yeah, thank you so much for sharing.
Yeah.
That's very encouraging for I'm sure for other people, being able to conquer some of those challenges that look like you couldn't conquer them before, using Git, pushing your code, being able to have your code on an EC2, being able to access it and all that. Well done, well done. I'll just say build on that knowledge. And the sky is the limit really. So thanks so much for sharing. I see comments from Eniola. You said last week we stopped at load balancers. Are we done with the AWS curriculum yet? Oh, so we are done with the um, AWS Solutions Architects Associates track. It doesn't mean like that we're not going to touch anything else on AWS. We even in Linux administration and shell scripting, we still have a few things that we'll touch, right? So, but just for that track, right, we've covered what we need to at that point. You mentioned other services like Route 53 and storage. Yes, for the storage, for instance, we will touch that within this track because it ties into what we are talking about in Linux administration. That's why we've kind of moved it here, right? So don't worry, we'll get to all that. We're just trying to make sure that the topics are, aligned with other topics that make sense. I don't know if you get what I mean. So that is more practical for you to use rather than just talking about them in isolation, right? Talking about them in a way where you can see, okay, this is why we are using this alongside this. For instance, if you see when we talked about the load balancer, we talked about auto scaling and all that, right? All those things tie together. It doesn't make sense talking about them separately. So yeah, we would get to them. But I still appreciate the feedback, and your life shows that, you are kind of looking forward to some things. You are doing your reading, you're seeing what things are about, what is available out there. So that's nice. All right, cool. Thank you to everyone who gave some feedback. Very much appreciated. I hope to hear more wins like, what Lekwan said. I'm sure every one of us has, some sort of win that we've had, an achievement, but we're not just sharing it. So, yeah. I congratulate you on that win, even though you have not shared it yet. So what we'll do is just kick off with today's class. So we'll be talking about Linux administration and shell scripting. It's a very, very important and interesting segment of the advanced tech ops class, right? Or module, let me call it. So if you have any questions, you can either note them down to when I ask for questions or, put them in the chat and I would come across to look at them when it's time for questions, right? So in this particular section of the course, we would have 5 modules, but we will take more than one module per class because this is going to span 2 weeks, this week and the next week. So we would be looking at shell scripting, basics, the introduction to shell scripting, understanding how to write and execute simple scripts, understanding the basic shell commands, some best practices, looking at variables, how to use them, how to declare them, conditional statements, case statements for decision making, functions and their role in shell scripting. Then we'll delve into AWS EBS volumes, right? Some best practices, some hands-on exercises. We'll look into things like bootstrapping at some point. We'll look into EFS, Elastic File System, file sharing permissions, integrating EFS with Linux instances. Then we'll finish off with AMIs and snapshots, right? For some of these things, I've mentioned them in passing in other classes, but we'll just take a deeper dive at them when we get to each of those sections of this course. Now, to shell scripting itself. So shell scripting is an integral part of the process of automation in Linux, right? It helps you write a sequence of commands in a file, then execute them. So shell scripting is, in a more simple term, it's like writing a to-do list for your computer, right? Your script, it's meant to list out the task you want your computer to perform. Then the shell interprets those tasks and executes those commands in the order in which you have written them, right? So if you're writing a to-do list and you're telling your computer that it should print hello world, then after that it should maybe install a Chrome browser. Then after that, you're telling it that it should delete that Chrome browser. It's going to execute that exactly in the order in which you tell it to do, right? And those commands that you put within the shell script, they have to be commands that are understood by the shell. That's why it's called the shell script. So the shell needs to know how to perform the commands that you have put in there for the shell script to run successfully, right? So the shell, like we've talked about in the past, is a command line interface that allows users to interact with the operating system. It acts as a bridge between the user and the kernel. It enables user to execute commands, to run programs, perform various tasks by typing text-based commands, right? So the shell is the main point of contact with the operating system. It's how you interact, it's how you speak to the operating system, how you change things. You think about it like your dashboard on your car. When you're driving, like you're able to kind of interact in a sense with your car by seeing like what is going on. You're able to get feedback on the speed you are going and all that. But shell scripts, I mean, the shell itself takes it even higher in the sense that you're able to do inputs, right? So you can think of the commands you are running as inputs that you do on your steering wheel, right? So you want to run a command to turn on the wipers, you just press the button for the wipers. You want to run a command to steer the car left, you do exactly that, you turn your steering left. So the shell script is just that point of contact, right? So in writing shell scripts, like I mentioned, it's like a to-do list, right? You write everything you need, you put it in a file, and it's interpreted and run line by line, right? So this gives you the opportunity to do all sorts of things as a DevOps engineer. It gives you the opportunity to automate repetitive tasks, right? Let's say you already have a certain number of commands that you run daily. You can write a shell script to run all those commands in order so that you don't have to type each of them every single time, or you don't have to copy and paste them. So it just brings that ease. It brings a level of automation. Because when you think about automation, there are different levels of automation, right? You can have like something that is fully automated end to end in the sense that you don't need to touch anything. It just runs on its own. But you have things that are kind of semi-automated. Maybe you need to run a command for the automation to start. But all of them, are some level of automation, right? And whatever automation you're able to do, whatever saves you time and reduces human error is very key to the DevOps concept, right? The DevOps culture, right? So, yeah. So shell scripting facilitates the process of continuous integration and deployment, right? By automating the setup, configuration, and management of servers. I talked about this, I think, a few weeks ago. I think last week, actually, when I was talking about working with auto-scaling groups and load balancers, because auto-scaling groups have the ability to spin up new servers based on the amount of traffic coming in. Those servers will need to be configured. I think this was a question, the answer to a question someone asked, right? So those servers would need to be configured for them to be able to have the required software on them, right? That will enable them serve the content that the user is supposed to get, right? In that auto scaling group. So the shell script can just have it can have all the commands to install everything that you need, and you run that prior to launching or adding that EC2 instance to the auto scaling group. And we'll come to that. There's a particular provision or facility that AWS has for doing exactly that. But I'm just giving you an idea of why shell scripting is useful, like in the DevOps culture, right? So it's also very useful for testing, actually, right? If you want to test things, you just want to make sure that things work consistently across, your development, your testing, your production environment. You can use shell scripts, to write the same test and run them across and, look at the results. So repeatability, automation is something that shell scripting provides, and it's very practical, or it's very useful, right, for DevOps engineers. Some practical uses of shell scripts, it's for things like batch processing. Let's say you want to work on a file. Let's say an example is you have a file, or let's say you have reports for 12 months, right? Reports for 12 months that have figures in them. And you want to take, and we know that the total, let's say the total income for a company is always going to be on line 6 of that file. Just an example here. And you want to retrieve the total for each of the months of the year for 12 months, and you want to maybe add them up together rather than having to, go into each file, look at it, put it in a calculator and all that. You can just create a shell script which goes through all those files repeatedly, does the same thing, goes through them, gets the total, gets the figure from line 6, and adds them together to get the total, like the grand total, and give to you, right? So that is batch processing, right? That's what shell scripting can do for batch processing. So you think about things also like automated backups. When you want to back up data, maybe to S3 or to some other place, you can have a shell script run all the commands that's required to back up that data. Then you can use what you call a cron job. I'm not sure I was talking about that yet, but a cron job is a feature that you have on Linux operating systems which enable you to schedule a command to run, right? So if the command you schedule is then that shell script, it enables you to run that shell script in an automated fashion without you, manually intervening, right? So you can perform your backups, let's say 11 p.m. or 12 a.m. every night using your shell script, right? So other things, you can use shell scripts for, like patching. You want to install updates on, let's say you have 300 servers. I've been in that situation before, working with Linux servers. I had over 300 VMs that we're working on, and we needed to patch each and every one of them, right? Of course, there are more expensive solutions to do those things, solutions that have agents that can do all that. But at some point, I mean, we didn't have that option. So I had to write a shell script, right? And, deploy that shell script to each of those servers and call that shell script on all of those servers and run the patches. And we were good, right? So you can use shell script also for system monitoring. You can use it to see what resources are being used on a system. If you don't have like a more professional monitoring tool, your shell script can continuously get data, and fetch it and put it somewhere where you can see it and visually analyze what is going on that system. Maybe it sends CPU metrics every 5 minutes, or memory metrics every 5 minutes, and all that. So I mean, it basically just frees up your time to solve more complex problems rather than worrying about menial, repeatable tasks, right? So very, very critical. The understanding of shell scripting for a DevOps engineer is non-negotiable. Like you would need it 100% in anywhere that you're going to work, right? Because if you are not writing the shell script to work using something like Bash, which would try, it might be using Python or something else, but you will definitely need to write it at some point or the other. All right, so cool. Let's look at the different types of shell, right? Because the shell is what enables shell scripts to work. Like I said, shells interpret the commands that are written in the shell scripts, right? So in the Linux world, a shell, like I mentioned, is just an interface for accessing operating system services. Linux supports several types of shells, each with its features and capabilities. Some standard shells we have include the Bourne shell SH. The Bourne shell is the original Unix shell. It's like the pioneer, the granddaddy of Linux shells. It's the basis for many other shells. Many other shells just built on the basic functionality that the Bourne shell provides. So it just provides basic functionality for executing commands, has fewer features, but it's just very simple, very effective in the way it does things, right? Then we have the Bash shell. It's called the Born Again shell. So it's an improvement on the Bourne shell, right? It's the most commonly used shell, and it's the default these days on many Linux operating systems. It can do more complex tasks, and that's what makes it like the staple for every DevOps engineer. It's quite powerful, quite versatile in the way it works. Then we have the Korn shell, Korn with a K, right? They call it KSH also, right? So the Korn shell is also an advanced shell. It incorporates features of the Bourne shell and the Born Again shell and the Bourne shell, right? It's often used in enterprise environments for complex, applications requiring robust scripting, right? So all this that I'm saying is really just for you to be aware of these shells. To be honest, most of the commands that you work with work the same across all of them, all the shells. They just have, some differences that will come up in one or two places. So just need to be aware of what they are, how they came about and all that. So the last one is the Z shell. It's very, very customizable. It has some advanced scripting features. It has things like spell check. It has theme support if you want to have themes for your shell. Maybe you want to change the color or whatever, right? You can do all those kind. It has advanced scripting, like I mentioned. So some power users, people that are very, very, that spend a lot of their time on shells, they prefer the Z shell, right, to work with. So, choosing a shell here is just, it depends on what you prefer. It depends on what you are trying to do, right? What purpose you want that shell to serve. That will determine what shell you choose, right? Or what operating system are you running? It determines what shell you choose. But to be honest, you would mostly be using the Bash shell for most of your career because it's sufficient for all that you have to do, except if you get into certain operating systems. I think maybe like, for instance, Linux Mint, if I'm not mistaken, I think uses is it Linux Mint now? There's a particular enterprise OS I'm trying to remember. Yeah, no, it's SUSE Linux. Yeah, SUSE Linux. It's an enterprise operating system. I think it uses Korn shell by default, but everything works basically across all of them because they have the same base shell. So let's look at the structure of a shell script. Like, how do you even write a shell script? How does it start? So A shell script is a sequence of commands like we've mentioned, but it always starts with what we call a shebang. Shebang. It's a word you hear quite often in shell scripting. A shebang. A shebang is a particular sequence of text, right, which you see on the screen here. This is the shebang. Sorry, let me move back. So you have it begins with the hash symbol or the pound symbol, then an exclamation mark, a forward slash, then bin, and that forward slash bash, right? So the if I would kind of break down the shebang, we can think about it as two separate entities. So we have the pound symbol or the hash together with the exclamation mark. Then we have the /bin /bash. So the /bin /bash is just a file path to the shell itself, right? It specifies the path to the shell interpreter, which in this case is bash. So the reason why I'm separating them is to help you understand that it would not always be /bin /bash. If you are using bash, yes, it will be. But if I was using ZSH or KSH, it would be /bin /KSH or ZSH. If I am using any of these interpreters and for some reason, the actual binary for that interpreter, that's like the program itself, is not located in /bin, then this would be different. For instance, if it's located in /usr/bin, then it should be /usr/bin /bash, right? So I'm just trying to let you know, you would most likely always use what you see on the screen here as the shebang, but you should understand why it is the way it is, right? Which is that if you're working on a bash shell, this here is the path, the file path to the bash binary. Then the first two symbols are just something that came with Linux, in the sense that it's kind of like a I don't know what I'll call it, maybe like a magic symbol or magic combination, just to show that this is the shell that you are going to use, right? It just shows that that's the shell that you're going to use. So the shebang should always be the first thing you write on any shell script, right? So that the interpreter can know, or the system can know, which interpreter it's going to use, right? So we'll see an example here of the shebang. Then we see a command app gets updates, right? Which will just update the packages on the Ubuntu operating system, right? So we'll look at some shell examples. I'll run through this and do a quick demo. Then we'll take some questions before we move on. So now in shell scripting, we've talked about what should be at the top, right? But we're going to talk about some other concepts, right, that are very critical in writing shell scripts and writing them in a way where they are very effective and efficient. Right, so we have what we call variables. Variables, right? Variables are used to store and manipulate data within shell scripts. Variables, think of variables. I know the concept sometimes can be hard if you have not been in the IT space, but variables, think of them as containers that store data, right? So you have any form of data, be it your name, you store it in a container so that whenever you want to retrieve the value for your name, you can use that container instead of your name. You can access it via the container instead of your name. So you ask the question, like, why don't I just write my name every time? Why do I need to use a container, right? So think of it, if it's a more complex data that you need to store rather than your name. Say, for instance, you had a whole sentence that you needed to store, right? And you needed to use that sentence like 10 times in your batch script. Instead of having to write that sentence 10 different times, sentence might contain maybe about 8 words. It's going to waste a lot of your time. So why not just save those 8 words in a single container, which can be maybe even just one letter. And you can use that one letter in the different 10 places that you want it to. So when you think about how much time it saves you, how clear it can make your code, you understand that variables are very, very critical. So there's a language we use. We say you assign a variable. You assign a value to a variable rather, right? So the value is the thing that you want to store in the container. The container itself is the variable, right? And the way you assign a variable here is by using a question, sorry, an equal to sign, right? So you would have the variable name on the left, then you have the equal to sign, then you would have the data you want to store in the variable on the right, right? So in this case, this example you are seeing here is saying, I want to store John in the variable name called name, right? So every time I try to access name, and we'll speak about how to access that. Every time I try to access name, it returns John because that's what is stored in it, right? I hope that makes sense, right? So when you try to access data that is stored in a variable, you access it by preceding that variable name with a dollar sign, right? So the dollar sign just indicates that I want to get the value of this variable name, not just having the variable name itself. I want to get the value of this variable name, right? So in this case here, which we will demo very shortly, when you do something like echo is a command that basically just prints out whatever argument it gets, that is whatever is in front of the command echo, it just prints it out on the screen, right? So if you put a dollar sign before the variable name called name, Echo would see that you are not trying to print out dollar name, but you are trying to print out the data inside that container called name, that variable called name. So rather than printing out hello dollar name, it will print out hello John because it's John that is inside the container, right? So one other thing to remember about variable names is that variable names are case sensitive, right? They can contain letters, numbers, underscores, but you always have to be careful when you name variable names so that you don't waste hours debugging very simple things. If you name a variable name with all lowercase and you're trying to access it with, all uppercase, it's going to fail. You won't get, the value that you expect. It will just be empty if it's not assigned, right? So you need to remember that they are case sensitive. Right. So I think what we'll do now is, okay, so one more thing, sorry, that I forgot to mention, user input. So when you're writing shell scripts, you sometimes want to get an input from the user in order to proceed with the actions that you're doing, right? So instead of putting the name John, defining the name John within your shell script, you can ask the user to enter their name. So if you ask the user to enter their name, whatever the name is, you can then store that name in a variable and use that name to do whatever you want to do. So it makes the script interactive. So it now looks like you're writing a program already, right? It makes the script interactive. It can accept input, read that input. It's just like asking someone a question and waiting for a response from that person. So you would now assimilate that response and you give them a feedback based on whatever response they give you, right? So that is a very useful concept and useful tool in shell scripting. So let's just jump in and take a look at some of the things we can do in shell scripting before I take some questions. So we'll just run through this example that we have here, right? So I was saying that if we want to, let me just make a new directory here, shell scripting 101. Let's just use that. So I'm just going to go into shell scripting 101. Cool. So if I want to create my shell script now, I would want to use a text editor, right? We have the text editor Vim. That's what I would usually use. So I'll now, give my script name, and I'll say, let's say greeting.sh, right? So you would usually, it is advisable to name your shell script with a name that ends in .sh, right? So I would say it is not compulsory in a sense, because the computer would still, the kernel will still know, what kind of file it is, right? What is inside your shell script. But firstly, it's important for your own understanding, so that when you see that file, oh, this is a shell script because it has .sh. So this is kind of like a general consensus across, Linux admins and people that work with shells and shell scripting. It's just good to name your file something.sh to show that it is a shell script, right? So as I mentioned, now that I've, used Vim to open this file, the first thing I want to write is the shebang, right? So that would be pound sign. Sorry, I'll use my I first just to insert, then the pound sign, the exclamation, then the path to the shell that I want to use, which is being sh, right? So that's the first thing that I would do, right? So as I've written this now, I can save it, right? You can either use WQ or, you can just use X, which I prefer to use. So I can save it now. I've only written the shebang, so I haven't done anything, interesting yet. If I try to run this script, you see that, nothing happens. So whenever you want to run your script, one thing you should always keep in mind, because it can give you a lot of trouble and, you'll be debugging for too long, is that you need to give your script permissions to run, right? People usually just use, a simple way you can do that is just to chmod, right? And do a +X. X is, we talked about this a while ago, X just refers to execution permissions. So a script needs those permissions to be able to execute, right? So you are saying add execution permissions to greeting.sh, right? So if I do that, now the way I will run my shell script is, there are two ways you can do that. You can either use the short form, which is just put a dot and a /, then the name of the shell script like this. Then it runs, or you can put the name of the interpreter first, which is bash, then the name of the shell script like this. So you are saying bash, please run the shell script, right? So whichever one works. So what I'll do is I'll try to run it with this short form and see, and you see that nothing happens because I didn't really write anything in there except the shebang. But if I use the bash to run it, you also see that nothing happens to it because there's nothing in there, right? So I will now put some content there. So we'll say name, we'll create a variable. Our variable is called name here. And we'll say the name is equal to, since Oyorinde has its name up, sorry, it's hand up, I'll just use his name in this example. So, or was that Lekon? anyways, here you guys saw my screen, so it's fine. So we say name is equal to you're there, right? Then I would say just checking. Oh, I should increase the font. Okay, that's why you guys are raising your hands up. Okay, awesome. Apologies for that. I would increase the fonts. Let me close this. So I think I should be able to just increase it. All right. Is it good now? Are we good? Yeah, thanks for the heads up. Better. Okay. So everyone can see it then. All right, great. So I have created a variable here by just putting name and the equal to sign and here, right? So I'm gonna say if I save this now, if I save this and I run a command again, you see that nothing still happens, right? Because the bash script I ran, just creates a variable. It doesn't do anything with it, right? But if I then come and try to echo, say hello, name, right? So I say hello name. So what should happen here is that Echo should figure out that because I put a $sign in front of name, Echo should figure out that I'm trying to access the data inside the variable name. So it should print hello and Oyorinde and not just print hello name, right? So let's try that and see what happens. Okay, so that has saved. So I'll try to run this and see. Seems to be lagging a bit. Not sure why, but let's just give it a second. Oh, a little more. Okay. It's here in this sense a little more. So let me increase the font. I hope that's better. I've increased it a little bit more. Right? Okay, cool. So like I said, I will try to run the command, the script greetings.sa. So when I run it, you can see it prints hello. But when we look at what is inside the script, you see that what I had was hello name, right? So that's just an example of how we can use variables. So another way we can use variables is by collecting input from the user and storing that input in variable. So if I do this, I say echo your name, right? And I say read name. So the read command, like I mentioned, it takes the input it asks the user for an input and it stores the value of that input from the user in whatever is put after it, which in this case is name, right? So name is a variable. If whatever you put after it becomes a variable, so it reads the output from the user and stores it in the variable here, right? Now, we can then use that variable like we did the last time and say hello name, right? So keep in mind that this name here is different from this name, but this name here is the same with this name, right? I know it sounds confusing, but if I want to make it less confusing, what I can say is read full name, just so you know that they're totally different things, and echo full name, right? So let's try this out and see how this works. So I can run my command greeting.sh, and it tells me enter your name. Okay, my name is Wisdom Ambulu. Then it says hello, Wisdom Ambulu. So it took that input, put it in a variable, and used it in the next command, which was the echo command, to print that out to me, right? So that's just a very kind of simple example as regards using variables and reading user input. So I'll just want to pause here and just, take some questions or some comments as regards this example we did and everything we've talked about so far on shell scripting, right? Anything you don't understand, anything you'd like to clarify. Keep in mind, this is just a very simple example so that you can understand the concept. There are so many things we can do, but we can't do all of them in this class, right? But we just want to give you the examples that can help you grasp the concept and be able to use it for whatever you want to use it. So there's so much creativity that you can have with shell scripting. We have Lekon with his hands raised, so I would allow you to speak now, but please, everybody else, you can ask your question. So I'll take Lekon's question first, please. Then we take Bolaji.
Hi, Wisdom. Hi, Wisdom.
Hi.
Yeah. Like I said in the beginning of the class, I said I have issue with this shell scripting. So my first issue is that I have issue using the editor, which is the basic editor. I was using Ubuntu, and the editor I think is the default editor in Ubuntu. And this is it. I always run into errors, especially what is okay. Let me give you an example. I saw a code online, then I decided to type it into my editor, and it's not running. And it was running on maybe on a website. Maybe you just Google a problem, and these are what I noticed at my assign, which is if I want to assign, let's say name equals to John. So now I noticed that the equals to has to be joined with, there shouldn't be space between name equals to John. Like everything has to be together. Is that true?
Yeah.
Was there are
Yeah,
times
yeah.
I will do that, it will work. If I don't do that, will it still work?
No, it won't work. We even have it's on the slide there. To assign the variable, use the equal to operator without spaces, right? So there
Okay,
has to be
fine.
no spaces, yeah, for that to work.
Okay, fine. When it comes to argument, like if I want to say, okay, I want to put an argument like I equals 0, then maybe hyphen, that what do I call it? Then you have another one, I equals to 10, or maybe less than or equals to 10. Now, what I want to take out is, should there be space between the I equals to 1, or let's say I equals to 0? You understand what I'm trying to say?
Yeah, so you separate those with semicolons, but with semicolons, yeah. So we'll come
Okay,
to that
after
actually,
the
because you're talking
semicolon, there
about
should be space.
loops, right? You're talking about loops, doing a loop.
Yes, yes,
Yeah. So we'll
yes.
come to that later
So
in the
my
slide.
challenge is
Yeah.
into I easily run into error. Okay, let me ask the last question, sir. Sorry for bothering you. So
Oh,
the
no
last
problem.
question is: would you advise to use a default editor, or would you advise use VS Code? Maybe we should install VS Code into the environment, Ubuntu environment. So that's my last question.
Okay, so what I would advise you to use, especially if you're using a remote environment, is to use the default editor, because you wouldn't always have the chance. A remote environment would most likely not have a GUI, right? And something like VS Code would need a GUI. You need to click and all those kind of things. So it would be good to be proficient on the default editor, which is Vim, because that is what is most prevalent across all Linux operating systems. So that whenever you come across any server that you need to work on, you know that you have the skills, the basic skills for text editing, right? Rather than having to struggle first to install, your favorite editor that you're comfortable with before you start your work. So you can easily just kick off anywhere you find yourself. Right. I hope that helps. Okay.
Yes, it really helps. Thank you.
Okay. All right. You're welcome. You're welcome. So Bolaji said, so Reed still expects prompt for an input. I'm not sure I get your question, but I think you're asking, you can clarify me if, or you can clarify if I'm wrong. I think you're asking if the read command, okay, expect / prompts, that's what you said. Yes, read prompts for an input. Yes, that's absolutely correct. Like you see here, so if I run that command again, you see that it just waits. That's the prompt. The prompt is expecting an input. So if I don't put an input, it will just wait here, forever. But once I put an input and say Bolaji, then I press enter and it finishes up. And even if I put the input, but I don't press enter, enter confirms that I'm done putting the input, right? If I put it and I don't press enter, it doesn't, complete the process, right? So I hope that answers the question. Chike says, sorry to digress, please. Are we finally through with the AWS solutions architecture? So I touched on this earlier in the class. Yes, we are through with the AWS solutions architect associate course in this program, but it doesn't mean that we're not going to do anything else AWS. We are through with like the basic things you need to know. The things you need to know, not just the basics actually, the things you need to know to go through that course, and be able to write the exam and all that. But there are still other things that we would touch as regards AWS. And the reason why we have, put them in other places is because we figure that there are other things that they combine with very well. For instance, when we're talking about shell scripting and we're talking about bootstrapping, we also want to talk about EBS volumes, right? We also want to talk about, EFS and the likes, because all those things, storage, sometimes has to do with what you are doing with shell scripting in a sense and all that. Like when we talked about auto scaling, we also talked about load balancing. So we like to bring concepts together that work together and not talk about them in isolation, right? So for the AWS Solutions Architect Associates track, because they're still like a professional, right? But just for the associate track, that's done. So we'll still touch on the other things you need to know as regards AWS in other places in the course, right? I hope that helps. So yeah, thank you so much for the questions. I don't know if anybody else has any question. Maybe not a question, but a comment. Like, does this make sense? What I did, does it make sense? Like, does it look useful? Maybe even while I'm doing this, did you try it? Did it work? Any feedback concerning that would be good to have before we click on. Although we'll still do a few more examples, right? But if no one has any questions, then we can just click on for the sake of time. But I'll give you just 1 minute more just to see if anyone has any questions or any comments regarding this. All right. Okay, so it looks like we're good. So what we do is just move on to the next thing we have. So the next thing we have speaks about conditional statements. Conditional statements, right? So shell scripts use conditional statements to make decisions and execute different code blocks based on conditions, right? So you can think about conditional statement like, crossroads on a map, or maybe more plainly, like when you're driving and you get to a T-junction, right? You have the option to go left, you have the option to left, and the option to go right. So if you go right, you end up in a different place. If you go left, you end up in a different place. Similar to conditional statements. It's like, okay, when you execute this block of the code, it does something. When you execute that block of the code, it does another thing, right? So the basic syntax for conditional statements are if-else statements, right? They try to make it as close to English as possible. So it's basically saying, if this is true, do this, else do that, right? So the else is basically saying, if the first thing you said is not true, then do that. So it's more like just testing various conditions for their truths and running a command based on their truthfulness or their falsehood in that sense, right? So as you can see here, the syntax usually begins with if, right? Then you would have the condition in front. Then you now have, you have a semicolon here just to indicate that you're done with your condition. Then you have a then statement. If you don't put a semicolon then it's not going to work. The semicolon separates your condition from, or the condition you're trying to check from the next thing, which is then, right? So then means, okay, yeah, we're done with this condition. Let's continue to what should happen if the condition is true. So if number, in this case, the variable number is greater than, -gt here means greater than 0, then echo positive number, right? Usually you just have else echo 0, which would just be like a simple true or false statement. But we have something else called elif. I know that is not very English-like, but elif just allows you to check additional conditions if the first condition is false. So if the first condition is false, you can say elif, that means check another condition. If that one also is false, you can do another elif. You can do as many elifs as you want. But you will always need an else condition at the end. So the else is basically just saying, if all the other conditions prior to the else are false, then the else would execute whatever is in that block, right? So thinking of this, practically, conditional statements are used for decision making in different systems. If you even look at the way artificial intelligence began, at the very primary level, it used conditional statement. Very primary level, it's more sophisticated now, but it's basically saying, if the user enters this, do this. It just had a bunch of conditionals that would respond in a certain way based on how, based on the inputs that the user gave, right? So in DevOps, conditionals are essential for creating robust scripts. When you're handling various automation tasks, let's say, for instance, you want to run a task on, your servers, but you want to check if those servers it's test servers, development servers or production servers. So let's say you have a variable on your computer on the servers that tell you that value. So you can just say, oh, if environment is equal to test, then do this. If environment is equal to development, then do this. If environment is equal to production, then do this. Else, don't do anything now. Whichever way. So just think of that concept. It enables you to write one script that you can use across different environments. The alternative to that would be to write separate scripts for each of those environments. But since you're able to run a conditional, you're able to do things in a more concise way, right? So we're going to look at a more Okay, no, this is the for loop. We're gonna do a practical demonstration of this just to show how this works. So let's create a file, a script called let's call it the if conditional, right? .sh. So we have the if conditional. We'll start with the shebang like we usually do, right? Then we would, let's write this command here, enter a number like we did the last time. Then read number. By the way, I don't know if I mentioned this before. When you write in a shell script, right? When you write a command, if the command is the only thing on the line, then you don't necessarily need to put a semicolon there, right? A semicolon in shell scripting acts as it basically tells the kernel that I am done with this particular command, right? You can start a new command. So this next, the thing I'm writing after the semicolon is not part of what is before the semicolon. So it's kind of like, it's kind of like the way we use full stop in English to say I'm done with this sentence, I'm starting a new sentence. So semicolon basically says I'm done with this command, I'm starting a new command. But in this case, for instance, with this echo command I have here, since this command is the only thing I have on that line, I don't necessarily need to write a semicolon, but I can do this, right? Just to show that, that would still work. So, because you see it in situations where we write multiple commands on a single line, and you see that we need to use semicolons, right? So interestingly, I can also even just move this here and it will still work. So for instance, if I do this like we did last time, and I say, excuse me, just had a little outage here. Just give me a second, let me sort this out. So I see serious question, says, is there a word for the dollar sign? No, the dollar sign is just called the dollar sign. There is no special word for it. Yeah, it's just called the dollar sign. Give me a second, please. Apologies. All right. So apologies. Let me just share my screen again so we can continue. So I was just trying to show that we can have multiple commands on a single line, right? So if we look at what I've written here and we do the same thing that I did the last time, that is to say, let's just say print or let me say the number is, let's say the number, right? So if I save this and I try to run this if conditional sh, yes, this is what will happen because I haven't given it permission. I just wanted you guys to see and remember the thing about permission. So if I then do this to give it the required permissions and I run it again, so it should ask me for the number. Number is 12. You can see it still works like before, right? Even though I have them on the same line. So the reason why you would usually put them on different lines is just for readability, like just to make your code more readable, right? So that you don't have your code, clustered and all that. I need to share my slides also. Just a second. So where are we here? All right, so I think this is where we are. So Great. Right. So getting back to the conditionals. So we talked about the if-else statements, right? So I'm just going to remove this now. So let's say we had, this script I wanted to write. We wanted to read a number and we wanted to check if that number is a positive number or a negative number, like we saw in the example on the screen. So we would read the number, store it in number, yes. Then we would check like this and say if number is greater than. So GT means greater than in this case, and LT means less than, right? So if the number is greater than 0, let me just put a space here so that it looks better. Okay. Then notice my semicolon here. Then I'll come to the next line for readability again. Echo positive number. So we know that if it's a number greater than 0, it's definitely a positive number. Then we can say, I can also put this here. We can say L if, that is adding another conditional, because now I want to check if it's a negative number, right? The reason in this case why I won't just go to else and say else negative number is because we can have 0, right? 0 is kind of in between, which is just, 0, right? So I'll say L if the number is less than 0, then it is a negative, echo negative number, right? Then I can say else echo 0, right? Then fee. So I didn't talk about fee. Fee is how you always end an if statement. I know the term itself might not make sense because fee doesn't mean anything tangible in a sense, but it's basically, just like the syntax for ending an if statement. Because if you end the if statement without that fee, you're going to have an error, right? So if you start with if, you stop with fee. Fee is just like if backwards. So I'm going to save this now. So what we've done so far is to echo an instruction for the user to enter a number. Then we're reading the number. Then if the number is greater than 0, then echo an output or print an output that it's a positive number. If the number is less than 0, print an output that it's a negative number. Else just print 0. So I'm going to run it now and we'll see what happens. Right. So okay, so I'm saying Chike say I wish to find out if there is no need to first state the variable in the example you gave, such as say number is equal to this. Maybe I'll come to that question after this, just a moment. Okay, so we have run this script now, and it's asking us for a number, right? So my number, the number I'm gonna put here is minus 23. So if I say, I press enter, it will tell me that's a negative number, and that is correct, right? If I run the script again and I put a number 64, it's going to tell me that's a positive number, that's correct. And if I run the command and I put the number 0, it's just going to tell me it's 0. So you can see that it catches each of those conditions and gives me the appropriate outputs based on the input that I gave it, right? So that's really how the if conditionals function, right? So Chike, I don't know, do you want to speak? Maybe I'll be able to understand you more clearly, just to address your question. Let me give you the right to speak here. So I'm giving you the right. You can unmute your mic and kind of explain what you mean. So if there's no
Okay,
need
good
to.
evening, Wisdom.
Oh, okay, go on. Good evening.
Yes, honestly, I was not hoping to interrupt I just left that message in case, I mean, at the right time you can address it. But since you've
Sure.
given me the opportunity, I really appreciate. Well, I don't know. I think the foundational knowledge I have about variables, you would, like I said, you have to define what number is so that when the computer sees what you mean by number, like what I'm trying to say is number is equal to that $sign. So for at every point that you might have to interpret what number means, you will refer to the definition that you have given, you first stated. I don't know if I'm making any sense.
Okay.
Now,
Yes.
so the question is now, in this instance that you stated, how is this like a different kind of syntax, kind of that the computer would automatically understand what you mean? Is it different from, are there particular ones that you might have to be able to first state these things before they can run smoothly?
Okay. Thank you so much for that question. I'll take us to this. So if you see in this particular scenario, right, we stated that name, which is a variable, is equal to John. So I think that's what you are speaking to, like you are defining the variable, right? Which is fine. There are situations for that, right? But if you see in this situation here, we are using the read command. Now, the read command, what it does is that it prompts the user for an input. Then it takes that input and stores it in the variable. So all that is happening behind the scenes, right? Because at the point it's happening at runtime. So when you run the script, all those action is happening. So the same thing you are saying is still happening in a sense, but you are not the one doing that. You've given that responsibility to the read command. You've told it when you collect with this command now, read number, what it says in English is prompt the user for an input, collect that input, store it in a variable called number, and hold it there, right? So that's why I know that when this line runs, a variable will be created with the input of the user. So that's why I'm able to confidently come here and reference that variable called number with the $sign. I don't know if that makes sense.
Okay, so are you saying the $sign? Because it made sense at some point that you now brought in the $sign number. So
the $sign, what it does, the $sign, what it does is it's used to access the variable, access the content of that variable, the data in the variable, right? So the variable name is number, but once you add the $sign, you are saying substitute $number with the actual value of the variable.
Okay.
So if the actual value of the variable is 99, yes. So in this case, you can think of this as if 99 is greater than 0. That's basically what the $sign does. It exposes the value of that variable.
Okay. So in a way, in a nutshell, for at the point you would need the read number, you do not need to predefine.
No, you don't need to predefine. Yeah.
Okay, it's fine. Are there particular cases where you have to now predefine to run?
Yeah, so I mean, we did one of those examples here where we had to predefine. So there are different options. If prompting a user for an input is not always going to be the solution, right? There are many situations, in fact, where you need to predefine the variables in that script and say this is what number means, right? Many situations. But I'm just showing you different possibilities, different things you can do. Depending on the use case, you choose the one that best fits it. Yeah.
That's fine. Makes sense now. Thank you so much.
All right. Thank you for speaking today. Thank you for sharing your question. Very, very helpful, I believe, to other people. So we will just move on to the next slide if nobody else has any questions. Conscious of our time. Okay, so let's just move on Maybe we can take all other questions at the end. So we've talked about if statements, right? Conditionals. Let's talk about loops. So think of loops as kind of like a repetitive exercise routine, right? Just as you would, let's say if you're one that loves to do push-ups, right? You would do a set of push-ups, maybe you're going to do 10 push-ups. You're going to do 10 of the same push-up. That's a repetition. You did 1, you did 2, you did 3, you did 4. Right? So a loop basically repeats something a number of times, right? It repeats a set of command. It may be a single command, it might be more than one command. It repeats it a set number of times, a specific number of times, right? So loops, from the definition we have on the screen, are control structures. They allow you to repeatedly execute a set of commands or statements. We have primarily 2 types of loops, right? We have what we call a for loop, and we have what we call a while loop. And so we'll talk about both of them. They are very, very simple concepts. Just try to grasp the context of it, like the use of it, why you would use a for loop and why you use a while loop, right? So a for loop in shell scripting, it goes through a list of items one by one and performs a task on each of them, right? So the for loop is used when you know in advance how many times you want to repeat a block of code. It iterates over a sequence of values, such as a range of numbers or elements in a list, right? Then it performs an action on those items. Let me give this most simple example. So let's say you have a number of fruits, right? You have an apple, you have an orange, you have a banana, you have a watermelon, right? And you want to blend each of these fruits separately, right? So using the concept of a for loop, right, what it would do is it will basically look at the items you have in that list, those list of fruits. So it would, since you have to have those that list predefined, basically you have to state that, oh, I have 4 fruits and these are the fruits. So for loop will look at it and say, okay, you have 4 of them. So basically I'm going to run through this, I'm going to run a particular action 4 times on these fruits. That is to blend them. So I'll blend the first one, I'll blend the second one, I'll blend the third one, I'll blend the fourth one. So that's the idea, right? So it could be a list of things. It's not just numbers. It could even just be a list of things, or it could be a range of numbers, and it would determine how many times it needs to run them, and run them, run the commands for those number of times, right? So when you're using loops, you always see the word iteration. Iteration just speaks about doing something incrementally, right? You do it the first time, you iterate. That means you do it again and again and again and again, right? So imagine you have, like I mentioned in the example, you have a list of files, and for each file, you want to print the name of that file. So a loop will enable you to perform this action very efficiently, because it can go through those lists of files and do exactly that for you, right? Loops can be used for batch processing, like I mentioned at the beginning, when you want to do something multiple times on a number of files or documents, whichever one, right? Let's say you even want to resize certain images. Let's say you have 50 images, they are all in a particular aspect ratio, right? Which is maybe 200 by 200, and you want to resize them to 100 by 100, and you have a command that says resize space 100 by 100 space image, and you want to run that command on all those images, you can use a loop for that, right? It works very, very nicely with that. So we're going to go through, because for shell scripting, it's mostly about just the practical of writing them. we're going to go through a practical to show how writing a loop would look like, right? So I'm going to save this, keep this, and create loop.sh here. So we start again with our favorite, with our favorite shebang here, /bin/bash, right? Then we would say, okay, we just print a message out saying that we want to count from 1 to 5, right? That's what we want to do. So we're going to write the command. So the for loop, the way it works is you use the command for, then you put your item list, or let me say your series, right? And I'll give a bunch of examples that we can use for those series. You put your item list. So in this case, the item list can be something like I in, and I'll explain this, I in 1 to 5, right? So this case is like a range. That's what I'm doing. So what this means here, what I've written. So I'm saying for, then I'm saying I'm creating a variable here. This I is a variable. Then I'm saying I should get assigned a value from this range. So this value, let me even use a simpler example to start with. Let me see. Let me use a simpler example. Let me see if we can do something like let's try. Okay, let's do this first. I'll do the simpler ones after this, just for the sake of time. So this, what I've written here is a shorthand way of just writing 1 to 5, right? Which is 1, 2, 3, 4, 5. Every number between 1 and 5, right? So what I'm saying here with this part of the command is saying, create this variable called I and loop through 1 to 5, iterate through 1 to 5. That means it would run through, it would perform that iteration 5 times. So on the first iteration, or on each iteration rather, assign the value of the current number to I. So that means the first time it runs, the variable I will be 1. The second time it runs, the variable I will now be 2. It will no longer be 1. The third time it runs, the variable I will be 3, and so on and so forth till it gets to 5. Then it stops, right? So basically, I is a variable that represents the current value in that iteration or in that loop. So if we are going all the way to 100, at the 50th iteration, I will be 50. That's basically how it is, right? So this first part is you always have to have your for, then you kind of have to have your the iteration that you're trying to perform. You have to have a variable that would store the current value in the iteration, but you also have to have your series or your range here. This is a range, right? So now the next thing we'll need to do here is to come to the next line. So in this one, we don't have like the then that we have in using if statements. What we do is just come to the next line here and we put do, right? Then what we do here is to write the next action. Sorry, to write, not the next action, to write the action that we want to happen repetitively. So now we said loops are meant to run a certain action repetitively, a defined number of times. So we know that we want to run an action 5 times, all right? And we want to store the current iteration number in this variable I. So what I'm going to do here very simply is just say echo I, right? Echo $I, which is the value of I. So I'm just trying to show us what the current iteration is at every point in time, right? So remember, after the do, it has the actual command you want to run repetitively. So after you do that, to close off the loop, you use done. So the structure is, I think we looked at that here. The structure is for, then variable, in, list, do, then the commands to be executed for each iteration, then done, right? So you write for the variable, in is always there, for is always there, do is always there, done is always there. So that's something to keep in mind. The things that change are the variable name, the list, and the commands that are to be executed, right? So let's run this and see what it gives us. So I'm going to give it the execute permissions as usual. Then I'll do this. So you see that it says counting from 1 to 5, then it prints out 1, 2, 3, 4, 5, because that was what was in the list, right? Let me try something slightly different. Let's just do this and see if this works. I think this should definitely be, so, okay, yes, exactly. So this is what I wanted to do. This is another version of what we just did. So instead of writing 1.5, I can just create my list, just list them out here as 1 to 5. So I, which is the variable, would, get assigned, this loop would run 5 times because there are 5 items here. Then I will be assigned the current value in the list every time it runs, right? So if I run this, I will get the same result like what I got the last time. Now, this doesn't only apply to numbers, right? So it could be a list of different things. So let's try using a list of names, right? So let's say, let's use Ada, let's use Wisdom, let's use Wisdom, Shagun, and let's use Valiant, right? So let's see what happens if this runs or if we get an error. So you can see that it loops through all those names also. So it's not just about numbers, right? So if I wanted to write something else, like use the value of I in a different way, I can say I is student at Dare.io. So I save this and I run the command. You see, it says Ada is a student at Dare.io, because I'm a student at, and it does all that, right? So that is the concept of using a for loop. So it just works on a list. It picks out each item in a list, assigns it to a variable, then enables you to use that variable to run whatever commands you want to run. Now, keep in mind, I can actually run a command that doesn't use the variable, but I mean, I'm sure you would imagine that that's not very useful. But I can just run a command. Let's say I'm running the command called Apple. Sorry, echo Apple. The command is not Apple. The command is echo Apple. So all it will do is just run the command the number of times that is equal to the length of this list, right? I mean, the list is 5. It has 4 items, so it will just run 4 times, right? So if we try it now, I'll do this. It just writes Apple 4 times. So I'm just trying to show you that you don't necessarily always have to use the value of the number or the value in the list. It's just that, it makes more sense to use a for loop for that situation. But you can just use a for loop to run a certain number of times based on the length of your list. Length of the list here is 4, so it ran 4 times, right? So that's really the basics for loops, right? I'll just cover while loops also, then we'll just take some some questions, because while loops are similar, but just slightly different. So a while loop is used when the number of iterations is not known. So remember, for for loops, we knew the number of iterations because we know the length of our list, right? In this case, we might not know the number of iterations beforehand. And while loops are determined by a condition. So it runs repeatedly and executes a set of commands as long as the condition specified is true. Now, with while loops, you have this syntax. You have the command while, then you have a condition following that. Then the same thing like for, you have like you have the do, you have the commands to be executed as long as the condition is true, then you have the done. Right, so you have while, condition, do, commands, then done. Right, so the condition, whatever you write as a condition would be, what the shell would do is to check if that condition is true or is false. If the condition is true, then it will continue running the commands here. But as soon as that condition is false, it will stop running the commands here, right? So a while loop is quite handy when you are reading the lines of a file and maybe you want to stop whatever commands you are running, whatever actions you are doing when there are no more lines to read in the file. Or maybe when you are monitoring, you are doing some sort of monitoring on a server and you want to continue checking the status of the server until that server is active, right? Let's say you are trying to spin up, a web server, right? And the web server takes maybe between 30 seconds to 1 minute. And you want to know when that server is up so that you continue with maybe other commands you're running. You can use a while loop and say, while let's say web server is down, continue to check or something, right? While the web server is down, continue to check, continue to check, continue to check. Once the web server is up, that means that condition is no longer true, then you can go on to the next piece of code, right? So you usually use it for times where you want to wait for something to happen. You're waiting for an action to be true or an action to be, you're waiting for an action rather to be true or to be false, depends. If you wanted to execute the commands within the while statement, you're waiting for the action to be true. If you wanted to execute the commands after that while statement, you're waiting for the for the condition to be false, right? One thing to note about while loops is it's very easy to go into something called an infinite loop. And I'll try to show an example of that. An infinite loop is a situation where the condition is always true. The condition will never be false. So the loop just continues going. Like it will never stop. If your laptop is still on, it will just continue going. And that can, hurt the resources of your laptop. It can eat up some of your CPU time and all that, right? It can hurt the performance of your servers if you have an infinite loop running. So you have to be careful with that. You have to write your commands in a way, or write your loops in a way where there's going to be a condition for it to stop, like a condition where it will be false at some point in time, right? So in terms of where we can use these loops, like I mentioned, it's very critical for situations where you're waiting for a process to finish or for a server to become available before you move on to the next step of something. So let's just look at a very quick example of infinite loops, right? So we'll just run through this loop. I'll just explain it before we go through it. So in this example here, we are setting a variable called counter. We are setting that variable to 1. We are assigning a value of 1 to that variable. Then here is just a print statement. Say, we're counting from 1 to 0 using a while loop. So similar to how we did with the for loop, counting from 1 to 0. But now we are saying while the counter is less than or equal to 5. So LE means less than or equal to. Remember, LT means less than, right? So while the counter is less than or equal to 5, do echo counter. That means it should print the counter. Then we have this very interesting statement here, right? The counter plus plus that is into brackets, right? So what this statement here means, this counter plus plus is basically saying increment the value of counter by 1. That's the simple, explanation of what that is. So if the value of counter is maybe 3 at that point, it's just going to increment it by 1 and make it 4. So the next time it's running, it will come back again and increment it by 1 and make it 5. Right. So the reason why we would use something like this is when we are starting from a particular number, I want to run a certain number of iterations. We need to be able to keep count of the number of times we've run that iteration so that we know if we have reached the limits. That is, let's say our plan was to run the iteration 5 times. We want to take note of the number of times we've run the iteration currently so that we can compare it with the original number of times we planned to run the iteration. So counter is keeping count of how many times we have run the iteration, right? So if counter runs the first time, it would have the value 1 because that's what we assigned to it. It will check, is it less than or equal to 5? Yes. So by the time it runs, it will not have, counter plus plus, increase that value to 2 to show that we're already done with the first iteration. So we are going to second iteration. So it will run it, check again, is it less than or equal to 5? And to increase the value to 3 and so on and so forth, right? So not a very, difficult concept, but we just need to understand why something like that would be used. So let's do a quick demo for this. Then I'll take some questions after that. So we can do a while loop .sh here and create a shebang as always. Then, like the example says, we say the counter is equal to 1. Then we want to echo counting from 1 to 5. Let's make it fun. Let's just make it 7 this time using a while loop, right? And let's just do this. Then we say while the counter is less than or equal to 7, do echo echo the counter. That's basically echoing the value of the counter. Then what we want to do here is to do a counter plus plus, which is to increment the value of that counter. Then we say just print out loop finished, right? So what will happen here, like I mentioned, is just you would see numbers from 1 to 7, right? Because this will continually increase the value. And at the point where this counter increases it and the value is 8, it will not run the next time, right? And I'll show you that. So let's just run this. Say, give it the permissions as always, while loop. Then we'll run while loop. So you see that it runs from 1 to 7, which is great, right? And it finishes as we expected. Now, if you see here, I ran this echo command here before the counter increments. That means on the 7th time, right, That means when the counter increments to 8, you don't see 8 because there's no echo command after the counter increments to 8. There's only echo command before the counter increments to 8. That means the counter was 6 here. Then when this part ran, it became 7. Then now went up again and checked. Is it less than or equal to 7? No. Then it didn't run again, right? So I just want to show you that the counter actually incremented to 8. So what I will do here is I would write another command here to say show count. Oh no, let's just say the counter value after incrementing is, then I'll just put counter, right? So I'm trying to show you, differentiate this from this, right? So let's save this and run it again. And you will see, all right. So you can see here that we had the counter value after incrementing is 8. So it showed that it actually got to 8, then it went to check if 8 is less than or equal to 7. Then you saw that that was false. Then the while loop now stopped. So while loops are just, they're very easy. They just work on the concept of testing that condition to see if the condition is true or not. If it's true, it executes what is in the do, done, between the do and the done. But if it's false, it just stops entirely, right? Okay, so we've looked at this. All right, so I think that's really our last slide for today, but I would love to take some questions. I'm sure we have some questions as regards the, oh, why can't I see the charts? Oh, okay, I can see it now. Okay, so we have Bolaji with a question. Please, Bolaji, go and ask your question.
Thank you very much. Good evening, all. Sorry, please. Well, I think I have a brief idea of, like, for example, PowerShell, using PowerShell to maybe create users within a Windows Server environment. Now, you mentioned one thing that I'm really interested in. For example, if you want to monitor if a server is down or when if a server is up now, that's automation. Is it possible to, like, give us an idea of what the script will be like? Because when you mentioned it, I'm trying to just, what will be the, okay, for example, are we going to use, like, okay, monitor, are we going to use the server name, or is it the IP address to know that this specific server is up now?
Yeah.
So,
I get what you're saying. Thank you so much for that question. All right, so let me see what example I can use. Okay, so usually, let me just give you the simpler answer, right? You would use a ping. A ping is what people most likely use. You need to know the IP address, then you just use a ping command, right? For instance, if I do a ping on 8.8.8.8, which is Google's DNS, which is always up, right? You would get this, right? So, but what I need to do is, let me test something and see if it's true. Just to show you an example. I don't want to do anything too complex to kind of confuse anybody, but let's just create something called server status very quickly before I come to Lekon's question. All right, so I would want to say, excuse me, I would want to say, like, let's say, wow, ping 8.8.8 to echo server is up, right? This would be this would be an infinite loop that I'll need to cancel myself, right? But let's just do something like this. Let me just test and see. So you can do a change mode plus X on server status. So guys, this is just kind of trying to answer this question. So we don't need to get confused on what is going on here. Just try to follow. So if I run this server status, it should show. Okay, actually, it's doing the ping itself. Okay, so you see that it goes continuously because it has nothing to stop it. I'm trying to see. So maybe it's I don't want to use too much time here because we have like 3 minutes, but I'll just explain it more in a concept, right? So in testing this, you would need to perform an action here like a ping and see if that is true or not, right? I want to test maybe if you do a ping to something that does not exist. Let me just say something like 192.168.100. It shouldn't exist. I want to see if that would give it. Okay, no, so that doesn't work, right? So you would need to do a ping and try to, in this place, you need to try to get the value of the output from the ping, right? So you know that usually when you do a ping, it should show you maybe something like 64 bytes, right? From whatever. So maybe what you can do is just to try to capture this part and check if the output of this ping returns 64 bytes in like the first two, statements in the output, right? Consider the server up, right? Or you can say if the value of this ping, if the output of this ping returns 64 bytes from that IP address you're pinging, print, or consider the server up. If it doesn't, consider the server down. I don't know if what I'm saying makes sense, Bolaji. So your test is going to be what is the response to the command that you're running against that server. And if that response is showing that the server is down, of course, your while loop should stop, right? Or if you want to check if the server is down, right? But if you want to check if the server is up, in a sense, you can keep pinging it until the server comes up. Let's say the ping usually, if the server is not up, we say request timeout, right? So you can say, oh, ping till you get this kind of output. And when you get this kind of output, then stop the loop, right? So it's pinging to test if the requests are timing out, requests are not timing out, then you stop the loop. So I hope that makes sense. I can't do like a full demonstration here because of time, because it will take a bit just to write that command, but I hope that helps a little bit. Really need the example you have given there. Really the example you have given answer the question. Oh, okay. All right, awesome. Great. So Lekon has his hand up, but he also asked a question in the chat. He said, I'm aware that there is an extension on VS Code that helps with debugging. Is there any extension in Vim that helps in debugging? And what's the difference between Sage Mode X and Sage Mode 777? There's no extension in Vim as far as I know that helps in debugging. Vim is a very simple text editor. It's not really a debugger. VS Code is a very, more complex and mature, text editing tool, right? Or code editing tool, whichever one. So it has a debugger. So simple answer is, there isn't any debugger. You have to use your your experience to debug in that case. Vim is very lightweight. Again, that's the reason for that. What's the difference between CH Mode X and 777? So the difference between that is CH Mode X plus X is only adding execute permissions. 777 here is, so chmod X is adding execute permissions for all users, right? So for users, groups, and others, right? When I say user, I mean the owner of that file, and it's adding execute permission for the owner of that file. When I say groups, I mean the group owner of that file. Then others is everybody else, right? But plus X only adds execute permission for everybody, right? The owner of the file, the group owner of the file, and others. 777 adds read, write, and execute for everybody. Plus X adds only execute for everybody. Maybe that's the very simple answer to that. That's why I usually prefer using plus X when I know I just want to execute something only. I don't need to grant everybody read write access, right? So Dekon, I don't know if that answers your question. Does that clarify things? All right, I see your hand is down, so I guess it does. An even simpler or safer kind of command to use in those situations is using chmod u plus X, which says the current owner of the file should have execute permissions, which if you created that file, you'll be the owner of the file, so you would still have execute permissions, right? So do we have any other questions on what we are on the while loop, that we mentioned, that we talked through rather? Any questions on the while loop before we wrap up for today? From next week, we will be looking at the next slides here, which speak about EC2 instance user data. Very interesting topic for automation also. So you can read up on that before next week. But if we do not have any other questions, we'll call it a wrap for today, since we are at our time. Thank you everyone for coming through today. Please try, some bash scripts out, test them out, write different things. Just see how it works. Bash scripting is very, very fun. It's very much fun, right? You can write amazing things. You can even make a lot of money with bash scripts. I'll give you a tip. I started off my let me say DevOps career just writing bash scripts alone. That was all I was doing, like in terms of freelancing. I did that for years and years and years. I'm sure I wrote over 500 bash scripts, at a point. It was very fun for me. I just enjoyed doing them. So if you get the hang of them, and understand, these different concepts that I said, try them out, practice them. It's very, very fun, very useful, very great for automation. And if you are in a team, in a DevOps team, and you are very proficient in bash scripts, you are good in automation, you'll be very, very valuable to your team. Trust me, you're very, very valuable to your team. So thank you everyone again. Please enjoy the rest of your weekend, and please, practice before next time. All right. Have a good evening. I'll see you next week.